Alright, welcome back guys. Today we're going to be doing lesson 8.3.2. What is relationship? Specifically, what is the relationship among distance, rate, and time? Throughout this course, you have been developing skills for writing equations to describe relationships in tables, in graphs, and in situations. Today you will use your equation writing skills to represent the relationships between rate, time, and distance. Core problem 95. Axel is getting his pig ready for the pig races at the county fair. During the race, 4 juvenile pigs run along a straight track, trying to be the first pig to get to a cream-filled chocolate cookie. His pig, Hammy, can run at a rate of 11 feet per second. So this sounds like a rate to me. We talked about in a problem when they give us a rate, it's always important to highlight that, underline it, make sure you guys are using that, 11 feet per second. Okay, and actually that's considered a unit rate because it tells us how far Hammy can run every second. So letter A says, at this speed, how far will Hammy run in 3 seconds, in 5 seconds, and in 1 minute, which is 60 seconds. And letter B then says, can we use that information to write an expression to represent how far Hammy will run in X number of seconds, so any unknown number of seconds. So go ahead and pause the video. We're going to give you guys go ahead and take as long as you need. Go ahead and solve A and B, and then we're going to come back and talk to you guys through that problem.
All right, so we went ahead and made a table here. We said that for every 1 second, the distance they went was 11 feet per second. So we are going to start with 1, 2, 3, 4, and 5. If we know that 1 second they go 11 feet, our rule here is we're going 11 feet every second. So in 2 feet, we're going how many seconds?
22.
22. Dang. We notice that our rule is times 11. So we can go ahead and then fill in the rest of our table. 3 times 11, 53 feet. 44 feet, and 55 feet. Now, they want us to find 60. We can go ahead and make this long table all the way to 60, but that will take way too much time. So we can go back to our unit rate of 1 and 11. We can go ahead and add our 60.
Where we would multiply our time by 11 to get our total distance traveled.
Yes. So then we do 11 times 60.
And 11 times 60 would be?
660 feet for our distance. So go ahead and check your table, make sure you have that correct, and then we had you do B. So write an expression that represents how far Hammy will run in X amount of seconds. So if we don't know our seconds, we can use X as a variable.
Now remember in our table, the 1, the 2, the 3, the 4, the 5, and the 60 represent our time. Okay, so now we're replacing those values with X. And what did we do in each of these scenarios? We multiplied it by
11. So our expression would be 11X.
So letter C then goes on, if the racetrack at the fair is 150 feet long, we want to draw a diagram talking about the time it would take to finish, but we also want to write an equation. So from yesterday's lesson, Ms. Lanes, what would we do to write that equation?
We would just do 11x equals 150.
Yeah. So if we were to draw a diagram, okay, kind of like a number line, if we started at 0, okay, and then we went 11 feet, and then we went another 11 feet, and eventually, which is actually, 22 feet, and we would keep going until we got to 150, okay? So just like our table, we can eventually get to the distance we want. It may take us a little bit of time. We can actually do it. It just may take us some more time. The equation gives us a more direct route to that answer. So you guys can go ahead and pause the video, continue your diagram to get to 150 feet. Also go ahead and solve the equation that Ms. Lanzo wrote, 11x is equal to 150, and see if we get the same answer. All right, so I actually had to go ahead and redraw my number line here because I ran out of space. So remember that we're comparing 11 feet in 1 second. So every time I go 11 more feet, I'm going up 1 more second. So if I get all the way to the end of my number line here, after 13 seconds, I went 143 feet. And after 154 feet, I went 14 seconds. So we wanted to know how long it took to go 150. So we know that it's somewhere between the end of 13 and the end of 14. So somewhere between 13 and 14 seconds. So the number line here, the double number line, actually gives us a really good estimate as to where or how long it should take this pig to go that distance. If we go to the equation, we're going to get more of an exact answer.
So you did the inverse operations of multiplication. You divided 11 by 11 and you got 1. And then you did 150 divided by 11 and you should have got 13 and 6,300. So like Mr. Baldwin said, it's about or in between 13 to 14 seconds.
But even though this method here is a little bit newer for us, it actually in the end is going to be a lot less work and we're actually going to get a much more exact answer. Okay, so the number line here again gives us more of an estimate, but it gives us a strategy that we're comfortable using, that we can always fall back on. This idea of writing and solving an equation is going to become more important as we get into 7th grade next year and onward. Okay, solving equations, which is algebra. All right, so good job. So if we go back now to our next core problem. Which is 96. AJ and her sister are entering a 200-mile bike race on their bicycle built for two. On a training ride, they traveled 60 miles in 2.5 hours. They want to use this information to find out how long it will take them to finish the bike race. Draw a diagram for the situation and be ready to explain how you found your solutions to the questions below. So just like the hand me the pig in the previous question, we know that every 60 miles they traveled, it took them 2.5 hours. So our number line, again, if we start at 0, we know that after 60 miles, it took us how long? 2.5?
Yes.
Hours. So if we double that after 120 miles, it would take twice as long, which is 5 hours. I like to show it, and Ms. Lanzo likes to show as well, just in the table. It's a little bit more of a concise way to show that information. So here we know 60 miles takes 2.5 hours. That's the information given to us. And like we found here, 120 miles takes us 5 hours.
So then looking at A, what is their bicycling rate? So what is the unit rate per hour? So we're trying to go and see how many miles they rode in 1 hour. Can we use something in our table or on our diagram to help us get back to our unit rate of 1?
Well, I know if I divide this by 2, I would know that in 30 miles, that would take 1 25/100ths of an hour. Okay, so that gets me closer to it, but still not quite to 1 hour. But we want to think about what did we do there. We all know how to divide this by 2 and divide this by 2, right? Okay, to get us closer to where we need to be. So in our table here, what else could you be doing?
Well, I would do 5 divided by 5 to get 1, and 120 divided by 5 to get
24.
24, yes. Long division right there. So we know that they travel 24 miles in 1 hour.
Okay, so that gives you 2 different approaches to find out what the unit rate is here. So I really like that Ms. Lanzo said, hey, if I know that in 5 hours I go this far, I want to divide that by 5 to get 1 hour. So I need to divide my total miles by 5 to find out how many miles I would go in 1 hour as well. Because my method here, again, would give me an approximation on the number line, but I'm not quite sure that it's going to be very easy for me to find exactly how many miles I would go in 1 hour.
So now let's look at B. How far can they go in 3 hours, in 6 hours, and explain how you can use the rate of travel and time to find distance.
Okay. So we just found out that our unit rate here is 24 miles for every 1 hour. So we're going to go ahead and pause the video. You guys take a few minutes and go ahead and say, can you use that information? Can you guys add to our table here to find out how far they travel in 3 hours and in 6 hours? And how does that relate to the unit rate?
All right, so let's take a look at what we have here. So we were to find how many hours or how many miles it would take for 3 hours and 6 hours. So we went ahead, and my method, my way, me and Mr. Baldwin have different ways, is we know that 1 hour, they travel 24 miles. So I took 1 times 3 to get 3, or 3 hours. I would do the same thing over here, 24 times 3 to get 72 hours. And then in order to find my 6, you can also go back to your unit rate and do 1 times 6 and 24 times 6, or you can take 3 times 2 is 6, 72 times 2, or 72 plus 72 is 144.
So the important thing you guys want to remember is that in the very beginning we labeled our two things, our miles and our hours. And whenever they give you guys hours, you want to put that in the appropriate column. Whenever they give you the miles, you want to put that in the appropriate column. Okay. So when we get to letter C says if they bike 10 miles, how long will it take them? Okay, so in order to find out how many hours it takes us to travel 10 miles, we can look back at our unit rate. And how do we go from 24 to 1? Well, you would divide 24 divided by 24. How do you get from 1 to 24? You would multiply 1 times 24 to get 24. So knowing that rule, we can go down here, and if we're going this way, we come back up here, 10 divided by 24. So I went ahead over here, now that I trip. So 10 divided by 24 as a fraction is just 10 24ths.
Yes. And if we simplify that, we can get 5/12. You don't have to, but just if you want to. So then, 5/12 is, we don't know how many hours 5/12 is. So you're going to have to go ahead and convert it to hours. So 5/12 of an hour would be,
well, we know that 6/12 of an hour is a little less than a half. So 5/12 of an hour would be 20 minutes.
okay, so it's not 20 minutes. We rethought that. So 6/12 is a half, so we're thinking 30 minutes. So 5/12 would be a little less than half, so about 25 minutes. So 25 minutes he rides 10 miles. So now let's look at letter D. If they bike at the same rate for the entire race, how long does it take them to finish the 200-mile race? Using our chart here, our table, using our table, we figured out that we can use 10 miles to get to 200. So 10 times what gives you 200? Everyone? Right. 10 times 10, 20.
So that means we also need to multiply this side then by 20 as well. So 10 24ths times 20 over 1 would give us 200 24ths. Or 100
over
12. Depending upon, did you use the simplified fraction or did you not use the simplified fraction?
Okay, so 100 over 12. This equals to about 8 hours and 20 minutes.
And if you did the division here, you guys probably got 8.33. What that means is 8 1/3 hours. So that 20 minutes is 1/3 of an hour. So if we break 60 minutes up into thirds, each third will be that 20 minutes.
So now take a minute on your own. We're not going to come back on until the next until 97, but it says summarize in words the relationship between the distance the girls traveled, their rate of travel, and how long they ride the time.
All right, so if we go back and look at our table here, we notice that our distance, the miles, we divide it by our rate of 24 miles per hour to get our time. Or if you look at the arrow this way, we multiplied our time by 24, which is our rate, to get our distance. So that takes us to two different equations that you guys could have had. The most traditional one you guys will see is distance is equal to rate times time. So again, we took our distance, the miles, okay, and that's equal to our time in hours times the 24, times the rate. We can also write that as the distance divided by the rate gives us time. So again, we took our distance, we divided by our rate of 24 miles per hour to give us 1 hour, or the time. So these are the two different equations that we are going to use for the remainder of the lesson today. So going on now to question 97. It says a new high-speed train travels 300 miles in 1 2/10 hours. Lewis and Omar are trying to figure out how they can find the distance the train has traveled after any number of hours. So again, we don't want one specific number of time, so that usually indicates we're going to use a variable. Omar decided to draw a diagram to help figure out the problem. He drew the diagram below. So go ahead and take a minute, draw this diagram on your paper, and then do letter A. Find the unit rate for the train. Alright, so looking at our double number line here, we know that every 1 2/10 hours we go 300 miles. So we can go ahead and double that to be 2 4/10 hours, an additional 1.2 hours, we would get an additional 300 miles. So our unit rate here is we want to know how many miles are in 1 hour. So we would have to go backwards. We would have to multiply by something that's less than 1 or a fraction that's less than 1. So we can take this 1 2/10 and we can divide it by 2, divide it by 3, whatever, and try to guess and check that to get to 1 hour exactly. But we also know that if we are talking about miles per hour, that's a ratio. So miles per hour is what I want to compare. And we know from the problem that we go 300 miles in 1 2/10 hours. So remember, our labels are really important here. So if we go ahead and remember fractions is division, we take our 300 and we divide by 1.2, we're going to find out that our answer is 250 miles per 1 hour. So 250 miles in 1 hour is our unit rate. It's the rate at which we travel the distance in 1 unit of time, in this case 1 hour. So we know that if we go back to our number line, that 1 hour we have calculated is going to be actually around 250 miles. Okay, so again, the number line, the double number line here gives us a good estimate as to where we're going to be. Getting into the more algebraic approach, solving and writing equations, is going to give us an exact answer. So letter B says, how far will the train travel in 5 hours? So if we know that we travel 250 miles in 1 hour, and we want to know how far we go in 5 hours, we are just going to multiply that by 5. So that's going to give us 1,250 miles. You also could have shown that in a table, like Miss Lane just showed you earlier. Where we multiply 1 hour by 5 to get 5 hours, and we multiply 250 by 5 to get 1,250 miles. So two different approaches. So letter B says, how far will the train travel in 5 hours? We found that was 1,250 miles, and we were also asked to write an equation. So here's our distance. I'm sorry, this is our rate times the time gives us our distance in miles. Going back to the equation that we wrote in the previous problem. So question C says, work with your team to write a general equation to show the relationship between distance, rate, and time. Is there more than one way to represent the relationship in an equation? So we actually have already talked about this in the prior question, but go ahead and think about all the different ways that you guys can write distance is equal to rate times time. So back to the previous question, we came up with these two. Distance is equal to rate times time, and distance divided by rate is equal to time. Okay, those are the two we came up with based off of our table. There was a third one we also can come up with, which is the rate is equal to the distance divided by the time. So in your notes, you guys should have these three different equations that can relate distance, the rate traveled, and the time. All right, question 98, the last core problem for the day. It says, in problem 8-97, you wrote an equation to relate distance to the rate of travel and time traveled. What if the rate does not involve distance? Use the situation below to investigate this question. Fred was filling bags of food for families in need at the neighborhood food pantry. Fred could fill 6 bags in 15 minutes. Draw a diagram for the situation and be ready to explain how you found your solutions. So we want to know how many bags Fred can fill in 2 hours, and we want to know how many bags Fred can fill in 5/6 of an hour. So again, go ahead and pause the video, draw a diagram, and see what you guys can do to find how many bags Fred can fill in 2 hours and how many he can fill in 5/6 of an hour. Alright, so let's see how you guys did. So in this problem, we are comparing the number of bags we can fill and the time in which it takes us to fill it. So you'll remember in the problem that they gave us, remember we always want to use the rate in which they give us, that we can fill 6 bags in 15 minutes. So that's why we use the labels bags and minutes.
Okay, so in order to find out how many bags we can fit into 2 hours, which is actually 120 minutes, we're going to complete the table. So we went up by 15-minute intervals, but then we decided, okay, well, we can use some of the information we get throughout this to reach 120. So how do you get from 15 to 30? Well, you multiply it by 3. How do you get from 30, I'm sorry, not 30, by 2? How do you get from 30 to 60? Well, you take 30 times 2. How do you get from 60 to 120? You multiply it by 2. So then we went over here and you did the same thing. 2 times 6 is 12. 12 times 2 is 24. This board keeps going, flying backwards. 24 times 2 is 48. So you end up with 48 bags in 2 hours or 120 minutes.
Now, if you guys didn't understand the multiplying by 2, you guys could have continued to go by intervals of 15. You guys could have done 45 minutes and then 60 and then 75 minutes until you guys just got to 120 minutes. Okay? So letter A, we were able to find out that in 2 hours, 120 minutes, we could fill 48 bags. So letter B then says, how many bags can Fred fill in 5/6 of an hour? So remember that in this table, we compared bags and time in minutes. Okay, and we actually converted the hours into minutes here because we want to compare the same unit of time. Okay, but letter B is asking us now to compare the bags to still with time, but instead of minutes into hours. So we want to think about how can we compare the same data, but in hours. So over here, if we have 6 bags in 15 minutes is 1/4 of an hour. So we can do this exact same table, but now instead of bags in minutes, we can do bags per hour. So 6 bags in 1/4 of an hour. So we want to know how many bags Fred can fill in 5/6 of an hour. So we want to talk about what is the rule. Okay. So how can we go from 6 to 1/4 or 1/4 to 6? So we know if we take 1/4 of something, to get 6 wholes, we would multiply it by 24. So we did a lot with Twizzlers right before we ended the school session. So if we have 1/4 piece of a Twizzler, and we have 24 of those, we would have 6 wholes. Okay? So if we go backwards, we know that 6 divided by 24 would be 1/4, or 6 24ths. So now we have the rule to fill out any number that we would need in that table. So for example, 2 hours, if we follow this rule and multiply that by 24, we would know that in 2 hours we filled 48 bags, which is what we got over here. Okay, so using that same rule, we want to know how many bags we can fill in 5/6 of an hour. So using this rule that we came up with up here, we want to multiply that by 24. So go ahead and multiply that by 24 if you need some time to go back and do that. We'll pause the video for about 5 seconds or so, and we'll go ahead and talk to you guys about what that answer should be. So,
You should get 20.
126, which is 20. So if we multiply 5/6 by 24, we're going to get 5 times 24 is 120, and 6 times 1 is 6. 120 divided by 6, or 126, is equal to 20.
So as we move along to question C, it says, write a rule to generalize the relationship between the number of bags Fred can fill and the amount of time that he works. Be sure to define your variables. So we kind of already found the rule when we switched the table from bags to minutes to bags to hours. So what do you guys think that the rule is going to be? And make sure you define your variable. So tell what the variable is representing.
So we used, in our table, we used bags and hours. So maybe we use the variable B for bags and T for hours. T is the time. Okay, so how can we relate bags and time? So if you look at our table over here, what did we do to the number of bags? We took our bags and we did what to it? We divided it by 24
to get our time.
Which 24 was our rate. So the number of bags divided by our rate is equal to time. We also knew that we took our time and we multiplied it by 24, or our rate, to give us the number of bags. So that's the generic rule. We actually do know what our rate is here. So our rate was actually 24. So if we wanted to, we can go ahead and replace our R, or our rate, with what we know is 24.
So now looking at D, use your equation from part C to find the number of bags Fred will fill during a week, assuming he fills bags at a constant rate and that Fred works 36 hours in 1 week. So let's go ahead and use one of our equations to solve for how many bags he fills.
So if we want to know how many bags we're filling, we can look at these both, and they're both going to give us the answer, but one's going to give us the answer a little bit more direct. This one's saying that the number of bags which we need divided by 24 is going to give us our time. We know the time was, what, 36?
Yes.
So over here it's saying that the time times 24 is going to give us the number of bags. So since we're looking for the number of bags we're going to be able to fill, this one's going to be the most direct one to get to our answer. So we know that our time was 36 hours times 24 would give us how many bags?
864 bags. And make sure you label.
So we know that if he works more hours in the week, we're going to fill more bags. And if he works less hours that week, we're going to fill less bags.
So great job today. We will see you next week. Tomorrow is going to be a Google Meet, so looking forward to seeing all of you.